Hello friends, welcome back to our channel. In today's video, we are going to discuss something very interesting. Either you are a beginner, intermediate engineer or expert, all of you will definitely gain some knowledge in this video session. In this video session, we are going to discuss RAM versus CAM. RAM is a random access memory. If you are a digital designer, we use it in our day-to-day life. CAM is a little bit uncommon but has numerous applications. CAM stands for Content Addressable Memory. In this particular video, we will discuss the basic difference between RAM and CAM, and in the subsequent videos, we will discuss in depth that what are the applications of CAM, how we design CAM, and I will show you practically where CAM is utilized. And now without wasting much time, let us get started this interesting video session. Firstly, let us see the basic definition of content addressable memory. In CAM, you give data as an input and it tells you which address that data is stored or if it exists at all. Let me simplify it for you. For CAM memory, we give data as an input and that data it searches in the entire locations of the memory, and if it is able to search that data in the memory, it will give the address of that location at its output. Friends, to better visualize how RAM and CAM works, I am taking help of one of the Xilinx document. Its name is XAPP201. You can search it on Google. Friends, as we know that in a RAM memory, address is an input. I am considering only the read mode. So that is why address is the input and data is output. So whatever address you give at its input and whatever data will be lying inside that memory at that particular location, that data will come out of RAM. But in CAM, this is different. We don't give address at input. Unlike RAM, we give data at input. And this CAM memory try to search this data in all the memory locations. If it is able to find this input data at any of the location, it will give address of that at its output. Along with the address, it will assert this match flag to indicate that something is found inside the CAM memory. Friends, now one very obvious question may arise in your mind is, it's okay that whatever D input you are giving, it is trying to search the entire memory locations. But how that data is written inside the CAM memory? So basically friends, whatever I am showing on the screen, it is very basic level of understanding and the difference between RAM and CAM memory. In the subsequent part of the video, I will demonstrate that how that data is written inside the CAM memory as well. But before that, let us try to see some typical CAM applications. CAMs are used in telecommunications, networking, Ethernet, ATM switches and diverse protocol applications. Friends, though you will not understand clearly how CAM is utilized in these applications, but I promise you that in the subsequent videos, I will give you one CAM application. After going through that video, it will be very clear to you that how CAM is used in search algorithms, pattern checkings and surveillance applications. Friends, other important thing is I have shown very few signals at the input and output of CAM memory. Now let us see the elaborated pinout of CAM memory. And there only I will explain how data is written inside the CAM memory. Friends, before digging into the pinout of CAM memory, I want to tell you there is another very important type of CAM memory that is called TCAM. Ternary Content Addressable Memory. Ternary CAM is a type of CAM memory that can store and compare three values 0, 1 and X. X stands for don't care. In a normal CAM, you can store only 0 and 1 and you can compare also 0 and 1 only. But in TCAM, you can store 0, 1 and X and you can compare also 0, 1 and X. Friends, in a nutshell, we can say that TCAM allows partial matching, meaning you can ignore certain bits using the value X. Let me show you graphically so that you can understand it better. Friends, now I will explain TCAM behavior with the help of the graphical diagram. But before that, I would like to request all the viewers that it takes lot of effort to prepare such type of technical videos. If you like the stuff, please press the like button and you can share your feedback if any. Now let us see the TCAM behavior. Friends, this is a TCAM memory. Here I have already written some data in it. If you see very carefully, the last two bits, that LSB bits, are all X. So while writing only, I wrote don't care. That means I have not written these memory locations. So in each location, only 6 bits are written 1010 and the last 2 bits are don't care. That means I have not written them. Anyway, the writing part I am going to cover in the subsequent video. But in this video, we are going to cover the comparison part. So in TCAM, you have an input data bus. Let us name it as CMP_DIN. It is 8 bits. I want to compare this data 1100, 1000. But in TCAM, the specialty is there will be some mask data bus. If D input is 8 bits, then mask bus also will be 8 bits. Wherever mask bit is high, this TCAM is not going to care those 3 bits and it will only compare those bits where mask bits are 0. That means this TCAM is going to search 11001 in this TCAM memory. And these 3 LSB bits will be masked because in this data mask bus, these LSB bits are 111. Now when it will start comparing, it will be able to search here 11001. See, very important thing here. The next bit is 1 in this TCAM memory and in the data bus it is 0. They are not matching. But because this bit is masked by the data mask bus, so it will not consider this bit and it will give a match and the address will be 012345. This is how TCAM works and I hope that this idea of TCAM is clear to you. Moreover, the video length is becoming quite long, so to cut short this video, I am going to end it here only. And regarding the complete pinout of CAM memory, we'll discuss it in the subsequent video. And with this, I am going to end this video session. I hope that this would be quite informative and interesting for all of you. If you also like this video, please press the like button and you can share your feedback in the comment section. And in future also, we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.